In section 12.3, we're going to be looking at inscribed angles, which means an angle within a circle. So we're going to have to use some theorems to determine angle measures and arc lengths. We're also going to use some corollaries to those theorems to help us find angle measures. And then we're also going to use an arc measure in order to determine other needed values. So the first thing we have to know is, what is an inscribed angle? Now, I told you that an inscribed angle is an angle in a circle, but to be more formal, an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So you see here, here's my vertex, it's on the circle, and these two sides here of my angle are chords of the circle. Now we also have intercepted arc. An intercepted arc is an arc with endpoints on the sides of an inscribed angle. There shouldn't be a D here. And its other points inside the angle. So this right here, I have my two endpoints on the sides of that angle, and then everything else in the middle of this, that is my intercepted arc. Now, an important note here is that the measure of an inscribed angle is half the measure of the intercepted arc. That's very important. So the measure of this angle is half whatever this intercepted arc is. So let's look at some example problems using the knowledge that we just learned. So if I look at this first example, I see here that this angle, PQT, is 60 degrees. And PQT, if I figure out what the intercepted arc of that angle is, it starts at P, it goes to T, and it's everything in between. So A, well, I know that if this is 60, then this arc must be 2 times that. It must be 120 degrees. So A is 120 degrees. Now we also know that B is PRS, which means the intercepted arc for B starts at P and goes to S and includes everything in between there, which means the 120 and the 30. So the measure of this arc is 150 degrees. But in order to get our angle, we need to divide that in half. So we know that B is equal to 75 degrees. Now in an example 2, it says in circle O, what is the measure of angle A? Well, here's angle A. Here's the ends of my rays that make up that angle. And this entire arc is the intercepted arc. This is a diameter. Look at it. So diameter cuts the circle in half, meaning that out of the whole 360 degrees, this must be half of that. So 120 degrees. I'm sorry, 180 degrees. If this is 180 degrees, well, then my A is 180 divided by 2. So the measure of angle A is 90 degrees. Again, my whole circle is 360. This intercepted arc is 180. I divide that by 2 to get A equals 90. Here's a you-try problem for you to do. Now we've got some corollaries that we can go through. The first one, 2 inscribed angles that intercept the same arc are congruent. So because these 2 angles, A and B, intercept that same arc right there in the middle, I know that A and B have to be the same. The next one, an angle inscribed in a, semicircle. Semicircle is a right angle. So anytime, just like in the last example we did on that last slide, we had this conversation about how this is a whole 360, so this is half of it, which means 180. And to get to my angle, I cut that in half, I get 90. That's going to happen anytime. So if I have an angle inscribed in just half of my circle, in a semicircle, it must be a right angle, 90 degrees. And then the last one, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So they're always going to add up to 180 degrees. Okay, so let's look at some examples. The first problem, we are looking for the measure of angle 1, and I see that angle 1 is inscribed in just half of this circle. So it's inscribed in a semicircle, which means the measure of angle 1 is 90 degrees. In example number 2, I have angle 2 here. It's holding these two pieces. So let's draw in our arc there. Those are my two endpoints of my angle. I'm looking for the measure of this angle right here. Well, what's interesting is if I backtrack, this arc right here is also intercepted by this angle, the two endpoints of that angle, which measures 38. So if our red angle intercepts that same arc, it must have the same measure. So the measure of angle 2 is also 38 degrees. And then here's your you try problem. All right, we've got one more thing we have to talk about, and that's when the angle is not entirely inside the circle. It's formed by a chord and a tangent. Now when that happens, it's going to look like these two pictures here, something like that. And what we need to do is we need to take that arc that is still like an intercepted angle, or I'm sorry, an intercepted arc, and we're just going to cut it in half. So let's see what this actually looks like. In the diagram, SR is tangent to the circle. If the measure of PMQ, arc PMQ, is 212, so let me write that into the picture, 212 degrees, then what is angle PQR? So I want to know the measure of this angle right here. Okay, I have a whole circle here. This piece is 212. So in order to find this piece here, I'm going to take 360 and subtract 212. 360 minus 212 leaves me with 148 degrees. So this here is the rest of that circle. It's 148. Now, I told you that if you have an angle that looks like this, where it's like half in and half out of the circle, then we need to take this and cut it in half. So my answer is that the measure of angle PQR is 1/2 of this 148, which is 74 degrees. And then you've got your you try there. That's all. I will see you in class.